Let's take a look at how covalent bonds are formed when orbitals overlap. There are two types of covalent bond, sigma and pi. Sigma bond is formed by head-on or direct overlap of s to s orbitals, s to p, or p to p orbitals. The shared electron density is primarily located in between the two nuclei. That is actually the two regions here. Well, if you take a look at pi bond occurs when p orbitals of two atoms overlap sideways. So in this case, the overlapping region is indicated here, and the shared pair electron density is as indicated on this diagram. And as earlier explained, the sigma bond actually occupies the electron density in between the two nuclei. Okay, in terms of the difference between sigma and pi bond, firstly, for electron density, sigma bond has a single region, as observed here. But for pi bond, there's actually two separated regions. So hence, you will find that the sigma bond tends to be stronger because it's a single region and the shared pair electron is closer to the nuclei. And generally, pi bond is weaker. Maximum number of sigma bonds that can be formed between two bonding atoms is just one, because there is actually only a single shared region between the two bonding nuclei. But for pi bonds, you can have two, because you could have one set here, as you can have another set on these flanks. Later, we'll take a look at the example in nitrogen to illustrate this point. Let's take a look at some examples. So when hydrogen atoms comes together to form H2, they form a sigma bond because each hydrogen atom has an electronic configuration of 1s1, which is actually a half-filled s orbital. And so the two half-filled s orbital can do a head-on overlap to give rise to a sigma bond. If we were to examine the molecule HF, then you will find that hydrogen atom would have an electronic configuration of 1s1, so it will have a half-filled s orbital. But in the case of fluorine, you will find that you will have one half-filled p orbital. So in this case, this p and s orbital could overlap to give rise again to a sigma bond with a single shared electron density region. Finally, if you look at the example of F2, in both fluorine atoms, they both have one half-filled p orbitals. So both p orbitals will come together with a head-on overlap, giving rise again to actually a sigma bond and also a single shared electron density. The next example we look at is nitrogen. Nitrogen forms three covalent bonds. The first bond that is formed is between px1 and px1. That is actually the sigma bond. So indicated in the diagram C here is the sigma bond that's formed between the two half-filled 2px orbital. Thereafter, in A and E, A is here, E is here. This is actually the first P to P side overlap, which gives rise to the first pi bond. And the D and the B orbital could actually do a P to P side overlap as well. That gives rise to the second pi bond. So all in all, for the case of N2, we will actually have one sigma bond and two pi bond. For any covalent bonds, the maximum number of pi bond is 2.